there is a requirement for the generator to have two mainline circuit breakers. NFPA 110, which is the standard for emergency and standby power systems, requires that the generator have two mainline circuit breakers, one for the normal power supply and one for the emergency power supply. NEC 700.4c requires that the normal power supply main circuit breaker be located ahead of the emergency power supply main circuit breaker. The rationale behind this is that the two mainline circuit breakers provide redundancy and protection for the generator and the loads it serves. In the event of a fault on one of the main circuit breakers, the other circuit breaker will remain closed and provide power to the loads. This redundancy helps to ensure that the generator can continue to operate and provide power to the critical loads in the event of an emergency. Regarding sizing, the normal power supply main circuit breaker must be sized to carry the full load current of the generator. The emergency power supply main circuit breaker must be sized to carry the full load current of the fire pump plus the full load current of the emergency lighting. The main circuit breakers must also be rated for the locked rotor current of the fire pump motor. When designing an emergency power system with a generator serving both the fire pump and emergency lighting, several crucial factors related to circuit breaker sizing and coordination must be considered to ensure reliability and compliance with NFPA 110 and NEC 700.4c. Firstly, the normal power supply circuit breaker is dedicated to handling the generator's total output capacity. Its amperage rating must be sufficient to carry the generator's full load current. This ensures that the generator can operate at its maximum designed output without tripping the breaker under normal operating conditions. Secondly, the emergency power supply circuit breaker is specifically designed to handle the loads associated with life safety systems, namely the fire pump and emergency lighting. Its amperage rating must be sufficient to carry the combined full load current of both the fire pump and the emergency lighting. This ensures that these critical systems receive uninterrupted power during an emergency. This breaker must also be capable of handling the fire pump's locked rotor current. The locked rotor current is the high current drawn by the motor when it initially starts. Because fire pumps need to start quickly and reliably, the emergency power supply breaker must be able to withstand this high current surge without tripping, typically for a duration of at least 20 seconds, as mentioned. The NEC and NFPA 110 provide guidance on the required withstand rating for such applications. The specific overcurrent protection requirements for fire pumps can be found in NEC 695. These requirements are in place to ensure that the fire pump operates reliably during fire emergencies. The coordination of these two breakers is of utmost importance. The normal power supply breaker should be selective with the emergency power supply breaker. This means that in the event of a fault on the emergency power supply side, only the emergency power supply breaker should trip, leaving the normal power supply breaker unaffected. This ensures that the generator continues to supply power to other essential loads not directly related to the emergency systems. In addition, the generator's overcurrent protection must be coordinated with both the normal and emergency power supply breakers. The generator's overcurrent protection should only trip as a last resort, protecting the generator from severe overload or fault conditions. When selecting circuit breakers, several factors must be considered. Firstly, the continuous current rating. The breakers must be rated to carry the continuous current of the loads they serve without overheating. Secondly, the interrupting rating. The breakers must have an interrupting rating sufficient to safely interrupt the maximum available fault current at their location. Thirdly, the trip characteristics. The breakers must have trip characteristics that provide both overload and short-circuit protection while also allowing for motor starting inrush currents. In addition to the circuit breakers, other protective devices may be required, such as ground fault protection. Ground fault protection is required to protect against ground faults, which can cause equipment damage and pose a shock hazard. When sizing the circuit breakers, it is crucial to consult the manufacturer's datasheets for the specific equipment being used. These datasheets will provide information on the full load current, locked rotor current, and other relevant parameters needed for proper sizing. The NEC provides guidelines for sizing circuit breakers and other overcurrent protective devices. NEC 240 provides the general requirements for overcurrent protection, while NEC 430 provides the requirements for motor circuit protection. In conclusion, providing redundancy and protection for critical loads is paramount. By adhering to NFPA 110 and NEC 700.4c, along with careful consideration of sizing and coordination, the electrical system can provide a reliable and safe power source for these essential systems.